In this video, we will go through how to control the simulated robotic arm using the manual controls. Then we'll plug in a real robotic arm and control it using the manual controls as well. First, we need to launch the simulator program. And if you don't have this installed, please see the previous video in this series where we installed the software. So the first thing we see is the 3D viewport. This is the environment where the simulated Orion5 exists. Using the mouse, you can click and drag to orbit around the Orion5 robotic arm. Other controls include right-clicking and panning around, like this. And to zoom in and out, you can use the scroll wheel, like this. Now, there are a number of buttons around the outside of the simulator viewport. This one up the top here centers the view. So if you get yourself into a weird position where the robot's off screen or something, you can press this and it'll come back to the middle. The button in the bottom left here opens the control panel. These sliders can be used to manually move the robot around. This can be useful for testing out different positions, movements, or just having fun moving things around on your desk. Right now we're in tool point control mode, and you can see that by this label over here. Tool point mode means that these control inputs, these sliders, define where in space the robot's tool point or claw is. In academia, this is referred to as the end effector. Imagine there is a ball inside the claws of the robot. So these sliders control the position of that ball in the 3D space, and this ball is called the tool point. So imagine there's a small ball inside the claws of the robot. So the first control we'll look at is the turret control. So the turret controls the angle of the turret axis, and that rotates about the very center of the base, which is here, and it uses this motor to do that. So the range is 0 to 360 degrees, but the robot can actually move through the 0 point, which means the turret position will wrap back around to 0 again like a clock. The numbers on the left and right here show the current range of the turret slider. So if we move that slider all the way to the left, we'd end up at 240 degrees, and all the way to the right, we'd end up at 120. So if we want to move 45 degrees clockwise, we drag it to the right, and see the number next to the current position is incrementing slowly as we move. So if we wanted to move 45 degrees from where we were, we can just let it go right there. And see now 45, or roughly 45, is the center, is the current position, and the left and right numbers have changed, which means the range of the slider has moved by 45 degrees. So now we're at 165, before we were at 120. So if we move the slider all the way to the right, our current position is about 165. So looking at that slider that shows the difference from the current position can be useful if you want to move a precise amount from the last position. So say you want to move 30 degrees to the left. Well, you just change this until it says 30 degrees. And with the turret control, if you want to move in increments of say 10 degrees, you can sort of move the slider to 10 degrees and then just keep clicking here, and it'll move in 10 degree increments around like this. So there's just a few different ways to control the turret like that. So the next slider to look at is the radius. Now we'll move the view around to the side for this one, to visualize this one. So remember that ball, that tool point ball that's inside the claws? Well, radius is the distance along the ground between the center of the base, and the center of the base is where the turret rotates around. So it's the very middle of the base, to somewhere directly underneath the ball that's inside the claws. So that is the radius control. So currently we're sitting at 300 millimeters, which means it's 300 millimeters between the center of the base along the ground to where that ball is inside the claws. So we can bring that into about here is probably in this current arrangement in this current position, that's about as close as we can get in because of the length of the wrist. And then we can go out about this far until the robot's completely flat, which is about 472 millimeters. Say an object was 400 millimeters away from the base of the robot and we wanted to grab it. Say it was over here, like right here. First we'd line it up with the turret. Then we'd extend the radius out to 400, and we'd be able to grab that object at 400 millimeters away from the base. So you can see here that the radius control is moving a number of joints at once in order to achieve the desired radius. The next slider we'll look at from the side. So this is the height. Now the height controls the distance between the ground and that ball inside the claws, which is the tool point again. So it's currently sitting at 50 millimeters, but we can bring that up to 100 millimeters, 200 millimeters, and above, up to about 500 millimeters is the maximum, just like the radius. So as you can see, it's keeping the wrist parallel to the ground, and we'll get to how to change that angle a bit later, but it's just changing the height of the tool point. It's keeping the radius constant. So if you want to set the radius to 250 millimeters and bring the height up, see the radius stays at 250, but the height is changing. Attack angle controls the angle of the wrist relative to the ground. So right now it's sitting at 0, which means it's parallel to the ground. Now we can move this up to negative 45 degrees, which means we'll be attacking the tool point at 45 degrees. So if I bring this up to negative 45, you can see that the wrist and the ground make a 45 degree angle. So that's where the attack comes from. So we're like attacking or approaching an object at 45 degrees to the ground. Let's say you wanted to come down on an object from directly above instead of on the side. You'd set the attack to negative 90, so you're coming in directly above, and then you'd bring the height down and come down above that object. And if that object is 300 millimeters away, well, you can set the radius to 300 millimeters, and you can bring the height down and come down on top of that object like this. So the depth control can be used like a fine tuning to zoom in or out on an object. And you can see that here we're coming in to an object at about 45 degrees. And this depth control is actually changing the radius and the height. So instead of fiddling around changing the radius, changing the height, changing the radius, changing the height, to bring it in slowly at this 45 degree angle, you can just use the depth to like zoom in and out along that attack vector. Most of the time you want to keep depth set at 0, use it when you need, and then put it back to 0. And the final control to have a look at is the claws. Now these simply open and close the claws, and if we move the view around to show the front of the robot like this, maybe move the attack angle up a bit so we can see in there. This control brings the claws all the way closed and all the way open. And you can see there the rack and pinion action. It's missing the pinion because it's not an important detail for the simulator, but that's where the pinion gear goes. Now, the Orion5, whether it be the simulated or the real robotic arm, accepts joint angle commands. So in order to move the robot around, we need to translate all of these 6 controls into 5 joint angles to send to the robot. Because what the robot does is takes those 5 joint angles and applies them to each motor. So there's 5 motors, so we need 5 joint angles. These 5 numbers along the bottom of the simulator viewport here are actually the current joint angle values from the robot. These are the 5 numbers we need in order to set the robot to this position right now. And if we change the position, right now we're moving 3 joints at once. We're moving shoulder, elbow and wrist. All those values are changing. So in order to set the robot to any one of these positions, we need to know these 5 numbers to that particular position. So what's happening is there's an inverse kinematics algorithm running in the background of this simulator. It's taking in the value of all of these sliders and outputting these 5 numbers and sending them to the simulated robotic arm. When a real robotic arm is connected, it's sending those numbers to the robotic arm via the USB. So we can actually change mode into direct control by clicking this button. Now we have 5 sliders, and these are directly controlling these 5 numbers, these 5 joint angles that are being sent to the robot in order to change its position. So we're bypassing the algorithm by controlling these numbers directly. So now we can control shoulder, elbow, wrist, and claw directly. Claw and turret still behave the same way, but now shoulder, wrist, and elbow are the new controls. So the robot will come out of its case in a shape like this. Now you would have seen this in the unboxing video, which is the first video of this series. Before we can use the robot, we need to rotate the shoulder so it's at 90 degrees. Now this is important because the shoulder motor actually goes through a 2.83 to 1 gearbox. which means that for every revolution of the arm, the shoulder motor is rotating multiple times, about 2.8 times. So its absolute position encoder doesn't know where in that rotation it is unless we move it to a roughly known position. So that position is about 90 degrees. It just seems to be somewhere between 0 and 120, preferably well between them. So 90 degrees is a good reference point and it's easy to remember. You can also unfold the robot a bit more by setting the wrist and forearm to somewhere like that, and that's a nice easy position to get started moving the robot around inside the simulator. So your robot may have come with one of these quick mount bases. This is an old version. We have a nice new version now, which is a bit lower profile. And your robot may have come with one of these. This makes it easy to mount the robot to the desk without having to screw and unscrew the robot each time you want to use it. So simply line up the 3 points, push down a bit, and then do the final latching of those 3 clips. So on the Orion5 robot, the 3 buttons indicate the 0 point of the turret. So if the robot is facing directly away from the buttons like this, the turret is at 0 degrees. And this can be a handy reference point for lining things up in the real world. So now on the simulator, what we can do is, before changing to the real robot mode, let's press E-stop. And E-stop just means that when we connect to the robot, it won't try and move it, it'll just read the current positions and display them on the 3D model. So let's change to real robot. So you'll see, by clicking the simulator button, you'll see that there's now an Orion5 come up here. And this Orion5 ActCom7 is what it is on my computer, but on your computer it might be different. This just indicates the serial COM port that your robot is connected to. So a green ring around Orion5 means it's connected, and you can see that the 3D model has updated to be reading the current positions of the joints from the robotic arm. And you can see that our robot is in E-stop mode, which is what we requested before. So you can see if I press the button on the robot to disable E-stop mode is disabled on the real robot, and it's disabled on the simulator too. The simulator is being updated live from the robot. And I can also click on here to disable the robot, and you can see we've gone into E-stop mode. So when E-stop is enabled, the joints are locked solid, they're holding their current position. But if I turn on E-stop, either with the button on the real robot or the button on the simulator, the joints stop holding their position and are movable. So this, when E-stop is on, so we've got red ring here, flashing light here, that means we can move. That's the only time when we can move the robot around by hand. Otherwise you might break things, such as the gearboxes inside the motors if you try and move them while they're holding that position. So with E-stop disabled, we can move the robot around and see that the simulator is reading the current positions and manipulating the 3D model to show the current position of the robot. And so these 5 numbers along the bottom of the viewport here are updating live, as well as the 3D model. So let's disable E-stop, and the controls become active. So now we can play around with moving the shoulder. We're still in direct control mode. Elbow. Wrist. And the claw. Okay, let's change to tool point control mode, and let's see how our original 6 controls work on the real robot. So note that the robot is approximately 15 millimeters off the surface of the table here right now. So these heights are all relative to the bottom of the base of the robot. But because that base is about 15 millimeters off the ground, we have to add 15 millimeters to anything we measure relative to the ground here. So right now I'm measuring about 105 millimeters from the table to here, so which means that should be about 90 millimeters on the height value, and we can see here we're about 88 millimeters. So that's close enough, plus or minus a few millimeters for measuring error. And now to measure radius, we want to measure from the center of the base out to the end of the claw, and yeah, we have about 250 millimeters. let's see if we can use the controls to pick up some blocks that I've placed here. So let's bring the radius in a bit. Let's bring the attack up to -90, because we want to approach these blocks from the top. We could also approach them from the side, but because they're a bit close to the robot, we don't have that much maneuvering room if we approach them from the side. So as you can see, I've got the attack angle at -90 degrees, so we're coming down directly on top. Next thing I want to do is bring the turret around so that we're in line with the blocks. I want to bring the radius in, and that's about 160 millimeters. I want to open the claw all the way to grab the blocks. I want to bring the height down slowly, and now I can see I need to move the turret over a little bit. So we use a very fine control. There we go. So bring the height down, bring the radius out a little, and now we can close the claw to the point where we're just applying a bit of pressure to the block. And now we can bring the height up like this. Maybe move over here. Then we can bring the height down a bit further. We need our depth to go a little bit further. And we can open the claw to release the block. Now we want to set our depth back to 0 and bring our height up. Very nice. And that's how you control the robot using the manual controls. So have fun moving things around on your desk. It is quite entertaining. The other purpose of these manual controls is to test out different positions and different movements. So now that I have moved a block from here to here, I could go through that sequence again and sort of write down the current positions of all the joints at the key moment. So like at this position above the tower, when we come down, when we go back up, when we move across, and when we go back down, those 4 or 5 positions, I could write them down, put them into a script, and have the robot do that by itself again and again. And so that's how the manual controls and the simulator can be handy to aid you in writing yourself a script for the robotic arm. So in the next video, we will run a Python script that performs a sequence of movements automatically, and we'll step through the example code, show you how to edit code, and run it using the simulator.